Hey fellow problem solvers, Colfax Math. Here today we're going to go over domain, range, piecewise graphs. This is for our IB math class, pre-calc, algebra 2 class. Just a couple notations you really need to know to understand domain and range. The way you get good at math is by practicing, so have a notebook out, pencil out, pause the video, take some notes. When I have problems, do the problems with the video pause, undo it, and then watch how I do them. So to start with, our vertical axis is always y. It is our dependent variable. And our horizontal axis is always x. It is our independent variable. Domain is always attached to the x-axis. Range is always attached to the y-axis. I remember that x comes before y in the alphabet. D comes before r in the alphabet. It is much more common to work with domain than range. And all domain does is regulate the variables you're looking at. So it kind of builds a window over what you want to look at. You could build that window this way and just have two sides to the window. That would be domain. Or if you want to limit it this way, you could build two sides, a top and a bottom, with range. So let's just take a look at a linear graph. Let's say this linear graph looks like this. That arrow says it is infinite. Let's say it starts at -2. So this thing is going from -2 onwards forever. So that means the domain, the possible values for x, start right here and go this way forever. So you would write that domain as x can be any value greater than or equal to -2. If, on the other hand, let's say right at the end here, it had an open circle. So here's a new example. Go to green. If it had like an open circle like this, and it went this way, I do not include -2. So in this case, if I wanted to say the possible values of x here, I would just say x is greater than -2. If it wasn't an infinite graph, and it had a final point right here. Let's do this one in red. Let's say it started there and ended here at 6. Well, then I could say x is greater than -2, but it is less than or equal to 6. I include that equals because this equals 2 right there. If I wanted to regulate some of these on range, you could do that as well. Let's do a new graph right here. Let's say I have that graph that looks like this, and it's finite, and it stops at 6 here. I am looking at the range only, so I'm only looking at range here. So I'm talking about values of y. They are closed circles here and here. It starts at 0 on the y-axis up to 6 on the y-axis. So values of y are greater than or equal to 0, less than or equal to 6. Okay, let's go to a practice problem here. Pause the video and write out these equations, including their domains. This is a piecewise graph, and I got 3 different pieces. First thing I do is I draw a vertical line. It crosses at one place, so I know it's a function. So f of x is going to be a function of a set of equations. So you do this first with the video pause, and then unpause it and watch how I'm going to do this. So on this, oh, actually I need one more point here. Let's say like -5. So let's take a look at the black graph first. I know it is a linear function. I identify it first. Then I get a general equation, y equals mx plus b. This is a roadmap telling me where I need to go. M is slope. B is y-intercept. So I have y equals slope. I rise for and I run for, but I'm running this way and this way. So it's positive. 4 over 4 reduces to 1, plus my y-intercept, 4. So the equation of that line that goes on forever in both directions is y equals x plus 4. But I don't want the whole line. I have y equals x plus 4. I only want portions from here to here. So I only want values of x greater than or equal to -5 but less than or equal to 2. So this thing, you know, I'll do it dotted, goes on forever, but I don't want to include that portion of it. I want to cut it here and here. So I write that black line, y equals x plus 4, an infinite line. However, I cut it off at -5 and 2. Now, let's go ahead and take a look at this blue line right here. This is a horizontal line through 5. Right, this thing goes on forever here. So a horizontal line is going to be y, so it's going to be y equals 5. That's the y-intercept, and there is no slope, right? It rises 0 over a run. 0 over anything is still 0. I don't want all those values. I only want the values between 2 and 6. And actually, I've already included 2 on the black line. So I'm going to say for values of x that are greater than 2, but less than or equal to 6. Lastly, I'm going to take a look at this red line right here. It's infinite this way, and it's finite here. So let's see if we can figure this out. This is going to be, again, a linear function, y equals mx plus b. I can figure out my slope because it rises. It comes down from 5 down to 0, so it rises -5, and it runs from 6 to 11.5. So I have y equals -5 over 5x plus b. Then I can pick any point and plug it in. So I'm going to delete my x and y here, and then I'm going to plug in any point. This is an easy one, over 11 up 0. So y is 0. X is 11. I plug it in for y and x. This is -1. So I have 0 is equal to -11 plus b. Add 11 to both sides. B is equal to 11. If that red line continued way up there, it would cross the y-axis at 11. So my general equation to my specific, y is equal to -1x plus 11. That's my graph, so I write it out here. Y is equal to -x plus 11. I want to cut those values of x off at 6, and that's it, because it goes on for infinite values. This arrow is just saying it goes on forever. The 6 is included in the blue graph, so I don't include it in the red graph. This is called a piecewise graph, looking at domain and ranges and functions. Okay, hopefully that was helpful. Thank you for watching.